All right. Hey guys, welcome to another episode of Learn with Anirudh. Now, over the last couple of years, a lot of you all have been requesting for this video where you want me to explain linear search and binary search in a simple fashion. So, here we go. Now, ladies and gentlemen, linear search and binary search are among the most fundamental things that you should know when you're working with data structures. So, what are we waiting for? Let's get started. Fantastic. Now, what are we learning in this episode of Learn with Anirudh? Well, I want to start this out by giving you multiple examples to help you relate with linear search, to help you get related with binary search. Because I assure you, ladies and gentlemen, that all of you all have used linear search and binary search almost every day in your life over the past, and you still do as well. So, firstly, we're going to understand what linear search is, how it works, and where do we use it. After that, we're going to check it out practically. Of course, since we are all very Python oriented and programming oriented, it's a very simple way of how you can actually go about implementing this. So we're going to take a look at that. And then we're going to take a look at binary search, same things. I'm going to give you a lot of examples that you can relate with. And then we're going to take a look at understanding it by actually taking an array, a list, and eventually moving through the Python code by iteration. We're going to take a look at how the entire code works. It's basically, it works on a loop. So we're going to check out all of that, right? So without further ado, let's get started. Now, did you actually know that these concepts, right, searching and sorting, you might have heard of linear search, you might have heard of binary search, you might have heard of merge sort, all these various sorting and searching methods. And if you're a fresher who's preparing for your first job, these are some of the most important concepts that you will get quizzed if you're going to an interview, correct? Now, why is that the case? That is the case because these are foundational to everything you go about doing ahead. Even as most experienced professionals out there, some people tend to forget sometimes of how binary search works or sometimes about how you could implement that. And that is completely okay, as I've been telling you multiple times over the last couple of videos now. And at this moment, I really want to take a second to give you all my thanks because you guys are showing me an immense amount of support. And with your subscription, as always, I can get my content out to more people, and people who are willing to learn can definitely make complete use of this. And I hope with by the end of this video, if you haven't subscribed, I hope to earn your subscription with the same. Now let's get started with linear search. Let's get back to the old days real quick here. Do you remember when you guys were kids, or if you're a person who's in your 30s watching this video, you might have started this out with your first mobile phone. There was a time when we had the old keypad mobiles, not the smartphones of today, where if you had to call someone, it's a very simple task of calling someone, right? You have to open up your contacts and you have to actually scroll down manually one after the other. Now, if you had to call your friend whose name was maybe Meghana, you had to go all the way from A to M and then figure out where Meghana is. It's literally like one after the other. You have to go in alphabetical order, you have to go reverse, or you have to do something. There was no way of you actually searching the contact up and calling. Now imagine nowadays calling your friends are like is like what? It's a 10-second activity, open contacts, so just say, hey Google, call this friend. Back in the day, that wasn't the case. You had to manually go one contact after another, after another, after another. You had to do that all that while. I'll give you another example where linear search is very popular. Do you remember when we were all kids, the phone companies used to send these really fat phone books at home, because then even before the world of mobile phones, we had landlines, and with landlines you really couldn't save the numbers and all of that. So if you had to look up a number, you would have to literally find a registry of millions of people staying in that particular city. You had to go alphabetically through those names, find the number, and then dial it. You might have seen your parents or your grandparents do this, correct? Now, why are we talking about all of these old things? And since we're talking about linear search, you might be asking a question right now. Hey, we don't have old fat phone books anymore, and we don't have those keypad phones anymore. So, how are all of these relevant to our discussion here? Now, I'll give you another example where linear search is very relevant to you. Let's just say you're back home from your vacation from Himachal Pradesh, you're back home from your vacation from Goa or whatever it is. You're back at the airport waiting to take a cab or take a taxi and go back home. Now, in many of the airports where we have services like Ola, Uber, and all of that, you have to go and wait in a queue after you've booked your app. And these cab guys, they come one after the other. They all stand in a queue and they just pick up customers one after another. No one gets to jump the queue. No one gets to, get priority. No one gets to go through the backside and then just pick a cab and leave right then and there. You board at one point, so everyone has to wait in the form of a queue, correct? One after another. It's not like you can jump 10 cabs and go get in there and go back home. It might work, but 99% of the case, let's be honest, all of us will be annoyed waiting for a cab to go back home. And eventually, the ride back home can definitely, if you're in Bangalore, the ride back home will be longer than the actual flight you might have taken to land in Bengaluru, correct? So, that is again a concept where linear search is very popular. So some of y'all who might not be able to get complete picture of this, let's actually take a look at the data and let me give you an example. Here is a list of elements that you're seeing on your screen right now. I have 8 elements on your screen, correct? Now, if you're wondering about why we have something called 0, 1, 2, 3, 4, 5 at the bottom here, Python is a programming language that indexes everything from 0. Now, if you're reading a book, what is the first page? It's called page number 1, page number 2. So in real life, we don't start a lot with 0. If you have 10 people standing in front of you, you say you're the first person, you're number 2, you're number 3, you're number 4. You don't say you're 0, you're 1, you're 2, correct? But Python doesn't do that. Python indexes everything from 0. Just like how we go about talking about in real sense from 1 to 10 or 1 to n, Python does this, but it does this from 0, right? So if I ask you what is the 0th element, it'll be 10. What is the first element or the element which is in the index position 1? It will not be 10, it'll actually be 5. Get it? So instead of starting from 1, Python likes to start it from 0. Why does it do that? We're going to take a look at it. And if you guys know why, it's actually a very nice reason. So head to the comment section and let me know. Now, anyway, take a look at the list here, right? So we have a simple list with 8 elements, of course. Simple list with 8 elements. So let's just say that I want to find a certain element, right? Linear search is all about us searching for an element here. And as you can see, I have highlighted 1. Now what I want to do here is I want to find out where the element 1 exists in this particular list. Now you can quickly look at the list with your bare eyes and you can tell me, hey, that's in the 5th position. That's fantastic because your brain could really do the linear search in a second. But to get Python to understand this is a slight challenge. I'll tell you why. Python is going to start searching from one element after another in linear search. So first it looks at 10. It compares 10 to 1. Is 10 equal to 1? Not really, right? So then it just looks at the next element, 5. Is 5 equal to 1? No. Jump again. Is 6 equal to 1? No. Jump again. Is 2 equal to 1? Absolutely not. Jump again. Now we will land at 1 where Python asks a question saying, is 1 equal to the element that we're searching for? Now the answer is yes. As soon as you have found your element in linear search, you don't have to bother looking for the other elements because you've already got this. Now if you're looking for your favorite pairs of shoes at a Nike store or a Puma store, and as soon as you get it, there's a very good chance if you're very particular for that shoe, you'll go get it, come back home. Similarly here as well, once you find the element, there's absolutely no need to spend your time and your efficiency in searching for other elements because we don't care about those. We only care about 1 and we have found 1. So regardless of the number of elements that we'll have in this list, as soon as you find your favorite element, we drop the rest, we come out of it and we say, hey, this element you were searching for was in this particular position. Pretty simple, pretty straightforward, right? But one important thing you had to notice there, one important thing you will have to remember right now is that the elements are unordered, right? There's no order to it. 10, 5, 6, 2, 1, 4, 23. There's no pattern to it. It is not in the ascending order. It is not in the descending order. It is just random. And guess what? Even if you have random elements, linear search works very well. Now, why am I specifically mentioning this? And if you already have some idea about binary search, you will know that random elements will not work with the binary search algorithm. Anyway, when we get to the section, we are going to discuss that as well. But for now, I know all of you all are super curious to get started and take a look at what the code looks like. I promise you it's a very tiny snippet of code. So what are we waiting for? Let's quickly jump to Google Colab and let's discuss linear search practically. Okay, so as you can see, we have Collab up and running. If you want to find the exact Jupyter notebook that we'll be discussing right now, it's actually in the description box. So all of you all can actually run this code, execute it by yourself, put your own lists, find your own elements, and have a bit of practical fun. Now, since we're discussing linear search, take a look at this. This is actually super simple for all of you all to figure out, I promise. Now, when we're searching for something, what do we need? We need two things. One is the list where we'll search the element, and the other thing is the element itself that we're about to search. Take a look at this. I have a very simple list here which has a couple of elements. Again, unordered elements, random elements. You can also have negative elements here. We're only discussing positive, but you can have negative elements as well. Next, I want to basically run through it sequentially from left to right. And the logic here is I have to get Python to move across each element from left to right and figure out where it is in the position itself, because we are looking for the position in which the item is present or not. So we have a simple for loop that says, hey, take the entire length of the list that I have given to you and just move across it from one to the other. So what do we do after iterating? We have a simple if statement which says, hey, if you have the actual item at this position, the ith position, right? I will become 0, 1, 2, 3, 4, and it will go on and on. So if you find the element 9, 9 is the element that you are searching for. This can be anything, right? So if you find 9, just print us the position of it. Here, if you see, I've done a little bit of magic when I'm trying to print the ith element. Now, if I just say, take a look at it practically, right? Where is 9 in the list? 1, 2, 3, 4, 5, 6, 7th position. So 9 is in the 7th position when we read it from 1. But Python reads it from 0, so it's going to give you an answer which will be 1 less than what we are looking for. So all I've done is I've added 1 to compensate for it and bring it from index 0 to index 1. Let me click on the play and you can see that it says the number was found at the actual position 7. Now, if Python were to start from 0, it would say, hey, 0, 1, 2, 3, 4, 5, 6. It would say that it is at the 6th index location, but in literal terms, it would be at the 7th position, correct? So we wanted to find 9, we found it. Now, let's just take a look at 1, right? The element 1. The element 1 is at the 3rd position. So as soon as I run this, I should get the answer 3. But literally, what Python sees is that it is at the 0th, 1st, and the 2nd position. Get it? Python will always count 1 less than what you require. And at the end of the day, let's be very honest, this is a simple 3 or a 4 liner code, which is basically what linear search is all about. So whenever someone comes to me and says, hey, I'm finding it pretty difficult to grasp what linear search or binary search is, that's what I tell them. It's very simple once you figure out practical examples of where you might have used it and the logic behind it. Just run through each element, compare each element with the element that you want. Boom, you're done. Fantastic. Now let's get back to the presentation and let's discuss binary search. Binary search is something that is super fun because here binary search is a method that is pretty much more efficient compared to linear search, and it can be a little bit complex and confusing for all of you all. Now, I would suggest that you guys keep a pen and paper handy when we are discussing the practical aspect of it. But before we go to the practical aspect of it, again, I want to give you some relatability in real life. Let's just say that you are reading one of your favorite books or something like that, and you just want to go to a particular page. Let's say you want to go to page number 50. What do you do if you have to go to page number 50? Or even when you have to go to a page where you have read a beautiful quote, and of course you want to put it on your Instagram. So you have to go to page number 38. You know that it's in page number 38 and you want to click a picture of that quote. So you just randomly open the book. When you open the book, you will not actually land on 38. You might, but many cases you won't if it's a very fat book. So let's say you opened up the page and now you're at page number 50. So what do? Your brain literally makes a calculation saying, hey, 38 is smaller than 50, so let's start flipping it left. Now, if you had to get to 38 and you opened a page and you open page number 10, you realize that 10 is smaller, 38 is further ahead, so you start flipping right. Correct? Guess what we do in binary search? It's very simple to this. We have an anchor point called the midpoint, and we just either go left or go right, and we divide the entire search into two operations, and we just find it out in a binary fashion really quickly. In linear search, you are forced to go through each of the element. If you have 100 elements, you have to run through each of the 100 elements to find your favorite element. The best case scenario is that if it is in position 1, you get it. But if it is in position 100, you have to compulsorily look at all the other positions as well. You have to keep moving. Not very efficient. But in the case of binary search, you don't have to look through all the other elements. Once you start figuring out the process, there are chances where you'll find your element where you might have not taken a look at the other elements that are present in the list at all, because you don't need to do that. Now, I'll give you a small example. Take a look at the elements that you see on your screen right now. All the elements are unordered here. Now, if you remember what I told you in the linear search section, it is very difficult for you to use binary search here. Now, let's get back to the same book example that I just gave you. In the book example, you know your book page numbers are correct. It is 1, 2, 3, 4, 5. It is in the order. It is not random, right? First page is not page number 10, page number 5, 6, 2. No, then you cannot do the flip left or the flip right. So if you are using binary search, you have to make sure that your data is sorted either in the ascending order or in the descending order. But most of the algorithm that we implement will always be in the ascending order. So make sure that your data is sorted before you begin to work with binary search. Because if you randomly provide it without sorting, the logic is not going to work and you are not going to find the correct answer to it. So how do you solve the randomness? By quickly using a sorting algorithm. Now, don't worry, we're going to be discussing all the sorting algorithms in the next couple of videos. This episode is completely meant for the people who are looking forward to learning the core elements of linear search and binary search. So, how does binary search work? Let me give you a quick example. Take a look at your screen right now. There's somewhere around, how many elements do we have? We have somewhere around 8 or 9 elements on your screen. And let's try to find out one particular element here. Let's just say that I want to search for the element 5. First of all, step number 1 in binary search is to figure out what element you want to search. Now I know what element I want to search. I want to search for 5. So what is step number 2? Step number 2 is to make sure that your list is sorted, and then only you can get started. So in our case, I've already sorted the list for you. So there is nothing that you have to worry about. Correct? Fantastic. What is step number 3? Step number 3 is for us to go to the middle of the list and start the comparison. We're going to be splitting the list into a couple of small chunks. And in this case, I want to head to the middle element. The interesting point here is that as soon as I go to the middle element, this itself is the middle element, right, of the entire list. Now I've already found my element. We found it easily. So done. I'm not going to take a look at any of these other elements. I went to the midpoint. I found the element right then and there. So this is the best case scenario in the case of binary search. The very first comparison you do, if you find your element, done. You're never going to bother spending time and effort looking at the other elements. But let's take a look at the other scenario where now let's just say I want to find 3. 5 is still the middle element of the list, but now I want to find 3. So our brain is literally saying you open page number 5, but I want to get to page number 3. What do? Are you going to flip left or are you going to flip the book to the right? Flipping the book to the right is absolutely no use. So what am I going to do is basically find out if 3 is less than or equal to 5. In our case, yes, 3 is less than or equal to 5. So I don't have to look at anything above 5 and including 5. So it's very simple. All I'm going to do is I'm going to remove all of those because I know my element is in this tiny space. And guess what? After this, we're going to basically repeat everything from step 2 to step 5. Again, I'm going to find the midpoint. Again, I'm going to compare if my element is either to the left or the right of the midpoint. If it is to the left, I'm going to chuck everything to the right. If it is to the right, I'm going to do what? I'm going to chuck everything to the left. And at the end of the day, once you find the middle position, once you find where your element is, you will basically be eliminating elements left and right. And eventually you will find out where you need to go and at what position that your original element that you were searching for is present in. Now, theoretical discussion of this is very simple, right? Let's take a quick recap. We're going to find the lowest index, we're going to find the highest index, and we're going to find the middle index. After that, if we have found the element at the middle, we're going to stop searching because we got it. Many cases of the time, it will not be in the middle, right? So it's either going to be in the left of the middle or right of the middle. If we're going to make a guess now, we're going to say, hey, if 3 is less than or equal to 5, then we're going to chuck everything of all the elements that's present to the right. So if your guess, you make a guess, and if your guess was low, we're going to keep moving the list to the right because we know that whatever we guessed was way too low. Whatever page number we opened was way less than the page number that we had to go to. So we're never going to bother looking at that again. But if we do the opposite, if we want page number 38, but we opened page number 50, we're going to stop looking all to the right and we're going to start looking to the left. So we're going to keep doing this balancing act and then we're going to quickly land at our page number, correct? Now, enough of theoretical discussions. I know you guys are very much excited to take a look at this practically. So let's quickly head to Google Colab. And now is when you guys are going to need your pen and paper because I want to take you through of how you can actually go step by step to figure out how the algorithm works. Fantastic. Now I have Google Colab opened again. So let me open up the binary search part of it. Now I'm going to zoom in a little more so that you guys can see what's going on. Now, as always, what do we require first of all is the list where we are going to have to search the element. Now, I've taken note of the list, ladies and gentlemen. This is a sorted list. If it is not sorted, the logic will not work. Okay, done. So we have the list that we have to use to search for our element. Second thing, we need the actual element for us to search. Done. Second line is going to give us the element as well. Next, basically, we have a small function. You can implement it without the function as well. We have a function called binary underscore search, and here I'm providing the list and I'm providing the element that I want to search. Take a look at this. This is where the heart of the logic lies, ladies and gentlemen. Everything that I've highlighted right now is a simple while loop and a couple of comparisons, and you're going to understand what it is exactly that we are going to do. All right. So let's go through it one step by step and let us try to find out manually. First of all, element 25. 25 is present in our list, and at what position is it in? 1, 2, 3, 4, 5, 6th position, 6th actual position, and it is at the index position 5 because Python starts it from 0, correct? So we know where the answer is, but there's a good chance you will not know this if your list had thousands of elements. You cannot sit and count manually, so your algorithm has to be correct. Now take your pen, take your paper, because we're gonna be doing this very simple comparison here where our low is 0. When we say low is 0, what is the index element of the first position? 0. What is the index position of the last element here, which is high? Last element, even though we have 14 elements, Python will always start it from 0, so it's going to become 13, correct? 14 minus 1. So I've said, hey, take the length of the entire list, just subtract 1 from it, and now we are back to Python's standards here. So in this case, the low is 0, the high is what? High becomes 13, correct? High is 13. Fantastic. Now I'm just going to remove this because you guys already know index starts from 0. I'm going to put the hashtag again. Hashtag very important, just like your Instagram. Fantastic. Now, the next line is, it says, while low is less than or equal to high, do everything that you see here. Okay. Low is 0, high is 13. Is low less than or equal to high? Absolutely it is. So we're going to get inside the loop now. And then there's a logic which says middle equal to low plus high divided by 2. Now we need to find the middle position here, right? So we're just going to take the lowest index, take the highest index and divide it by 2, and that will give us the middle position. Now what is low? Low is 0. What is high? High is 13. What is 0 plus 13 divided by 2? 6.5, correct? Now, look at this. I have not done regular division. I have done something called floor division. Floor division basically removes the floating point values as we have discussed in my Python tutorial episode. And here we have to understand that the answer to this is not going to be 6.5, but what? It's going to be 6, only 6, correct? Fantastic. Now we know the middle value, right? Now write this down. Low was 0, high was 13, and your middle value was 6. We have to find out if we have to compare the index position element. We're thinking about the index position, just the position 0, 1, 2, 3. No, we want the actual element. So the next thing that says is if the sample list of the middle element is equal to element, return the middle. Right now, this is the case where you were looking for 5 and you found it at the middle position itself. Now, what is middle? Middle is 6 right now. What is the position? What is the element that is present at the index position 6? 0, 1, 2, 3, 4, 5, 6. We have 30, correct? Is 30 equal to 25? No, 30 is not equal to 25, correct? So this will never execute. And then we're going to come to this. So is 30 greater than 25? Is 30 greater than 25? Yes. So we're going to execute this part of the loop. Now we're just moving from the page numbers to the left or the right here. And we realize that we came to a position where 30 was very much high. Since it is already sorted, we can kick everything out from 30 and everything else, right? So we're going to remove the highest index from the 13th position. And now we're going to calculate it to be this. What was middle? Middle was 6. Now high is going to become 6 minus 1 and high is going to be 5. So low is 0, middle is what? Middle is 6 and high is what? High is 5 at this moment of time, correct? Now this is not going to run, but hey, we are still in the loop, so we need to go do this one more time. Low is 0, high is 5. We're going to get into the loop again, and this time we're going to do this transaction where 0 plus 5 by 2 gives us 2.5. 2.5 is not we need. We're going to remove the 0.5. So the new middle value is now, new mid is how much? It's 2, correct? So we're going to find out what element is present at 2. 0, 1, 2. That's interesting. We have the element 3 there. Is 3 equal to 25? No, 3 is not equal to 25 now, so we'll skip this. Is 3 greater than 25? No, 3 is not greater than 25. So we're going to do this now. Our low was 0 and we know our middle value is 2. So basically we're going to say, hey, low equal to 2 plus 1 and low becomes 3. Write this down. At this iteration, at this current iteration, our low is what? Our low is 3. Our high is what? Our high is 5. Our mid is what? Our mid is basically 2, correct? I hope you're following along with each of these statements right now. Now, we still couldn't find the element there, so let's run through the list again. Now, since we're going through the list again, we know the low and the high values, it's 3 plus 5. So middle element becomes what? 3 plus 5 by 2. 3 plus 5 is what? 8. 8 divided by 2 becomes 4. But let's see what is that 4. 0, 1, 2, 3, 4. We have 10. So 10 is not equal to 25. We're not going to bother running this. 10 is not greater than 25. We're not going to bother running this. And we're going to run this again. So the new low value will become mid plus 1. Mid is 2. But right now, mid is going to go higher once again. And our low value is going to become what? Our low value is going to become 4 right now, correct? We're basically trying to understand what the middle value is, and all we're trying to do is we're adding 1 to the middle value here. The low is 3, the mid was 2, high was 5. But, did we calculate the new mid value? Now, middle value became 4. So let me actually go about writing 4 for you guys. And now, low will become mid plus 1. So low is 4 plus 1. The new low is now 5. Okay, but we still didn't find our element. So let's go back again. What is the low? What is the high? Whoa, they're both equal right now. So is 5 less than or equal to 5? Yes, it is still equal, so we can go again. We're going to have to find the mid now. Mid is what? 5 plus 5 by 2. 10 by 2 is 5. If the sample list position of 5 contains your element, print it. Now 0, 1, 2, 3, 4, 5. Ta-da! We got our element 25. If it is equal, print it and return the value. How simple is this, right? Now I'm going to remove all of this and I'm going to execute it. So what index answer should we get? We're supposed to get 5. So let me execute this really quickly and you can see that our answer was 5. Okay, let's find some other element. Let's find the element, let's find the last element, 75. So the answer should be what? It should be 13 right now because Python starts from 0, 1, 2, 3 and it's at the 13th index position. Well, we got it. Let's find another one for the sake of it. Let's find 10. 10 is at which position? 0, 1, 2, 3, 4. As soon as I execute this, the answer is going to be 4. So, ladies and gentlemen, this very simply is binary search. All you need to understand is this logic. How do you find the middle? And once you find the middle, you either go about checking if the element is the middle, if the element is greater, if the element is lesser, and you just start filtering out elements. And at the end, you would have filtered so much that you are forced to arrive at the middle element. And that is when your answer is going to be the element that you're searching for, right? So this is really easy linear search and binary search, and I thought I will take this chance to convey all of this to all of you guys. As I told you, I'm going to be giving you guys a small quiz. Now that you know the logic, now that you know how to implement it, do take a second to hit the comment section, get to the comment box, and just find the element 5 in the list. Do a linear search for it, find the element 5. Do the binary search for it and find the element 26. And let me know if you guys could actually do this. And of course, if you require any help, head to the comment section. I'll be more than happy to help you guys out. But yes, these are your two very small quiz questions. Do not try to copy it from whatever you saw in the previous section. Just try to remember the logic. Try to write it down on paper. Try to manually trace the program like we did. And I promise you, it's going to be very, very easy. And I hope to see your answers in the comment section. Right? With that, let's quickly wrap up this video. I already told you that binary search is very much faster than linear search, but guess what? If you have a small number of elements, linear search is actually faster. And you can add hundreds and hundreds of elements to your linear search, and no matter what element you add or remove, linear search will not care. It will just search for it regardless of anything, and it does not require any sorting as well. But in the case of binary search will first of all not bother looking at all the elements. It is efficient enough to just start dividing the list one after the other and get to where it wants. It will not spend time looking at all the elements. But an important thing you have to realize is that while you're searching or while you're using binary search, if you add certain elements to the middle of the list, starting end of the list, it's going to basically mess up everything. So you'll have to start from the first iteration again. So adding or removing elements in binary search is going to affect the searching algorithm. So make sure you remember that this is the question that it's usually asked in the interviews for you guys, or they're going to give you a list and say, hey, can you quickly implement binary search for this and give me the answer? And of course, it always has to be sorted, right, ladies and gentlemen? Binary search will not work unless your list is sorted. Well, with this, I hope you guys are sorted as well. So take a second to hit that subscribe button to make sure you do not miss any further episodes. I have a lot of content that I'm already working on day in and day out for you guys. And I really hope you guys are as excited as me. And as always, I look forward to your support, your messages on LinkedIn, your content requests. And I'm just picking up everything one by one. And I'm just catering directly to your requirements. So if you want to learn a particular concept, head to the comment section or go to my LinkedIn, leave me a message, leave me an email, whatever is convenient for you guys, and I'll pick that right up and I'll find the easiest way to teach you guys that, and we can get started with that as well, right? So thank you so much, guys. Thank you so much for tuning into this episode of Learn with Anirudh. I sincerely hope you had a chance to understand linear search and binary search in a simple fashion. And as always, I'm looking forward to meeting you guys on the next one. Have a nice day ahead.